Hey everybody, this is Scott. Thought I would take the time again to do another hopefully quick tutorial. Typically I either focus on Phoenix or Ember, but I've been spending a lot of time recently doing stuff with WebAssembly and specifically with Rust in WebAssembly, since it seems to be kind of the buzz programming language that people prefer to be using. So I thought I'd do a quick tutorial to kind of walk through how we can write something in another language, in this case Rust, and import it into our JavaScript applications. I'll be using Ember just to kind of stand up a quick node server, but really we're going to be writing vanilla JavaScript, so it's really not specific to Ember in any way. If you're unfamiliar with WebAssembly, I actually wrote a pretty quick introductory WebAssembly blog post on the Dockyard website to kind of explain what exactly it is that WebAssembly does for us. A lot of the content you'll see out there is people talking about how they've written programs in other languages, and WebAssembly allows them to bring that to the web. But for me, as a front-end developer, I wanted to know what is it that I can leverage in WebAssembly to make my JavaScript applications better. And that's kind of what this blog post covers. But what we're going to do is just write something really simple in Rust. A really simple function is just going to add two numbers together. But we're going to compile it to WebAssembly and import that into our JavaScript app. And I'm going to make the assumption that, like me, you come from the JavaScript world, so you're not necessarily familiar with strongly typed languages. You're not familiar with lower level languages whatsoever. So this is going to be soup to nuts, kind of everything that we need to get up and running with something in Rust and then bringing it into our JavaScript application. And I'm on my personal computer, just to kind of show that I actually don't have Rust set up whatsoever, just so I'm really making sure I'm not missing any steps. If this is something you're interested in, there's not going to be anything I have installed that we're not going to cover here within this. So the first thing we want to do is actually install the Rust language. So just go to rustlang.org and there follow the install link, and we can just simply copy this and paste that into our terminal. It will prompt you to what type of installation you want to do. We're just going to do one, proceed with the installation. I don't know how to customize it necessarily. So once that is installed, one of the last things you see here is asking you to set this up in your current shell. Oops. I copied the whole entire line apparently. So we just want to run this one thing, source home cargo environment. So now if we run Rust up in our terminal, it'll show us what version we have. And also if we run cargo-v, we can see what version of cargo we have. So Rust app, that's the tool chain that manages Rust on your computer. Cargo is the package manager for Rust. So if you're coming from the front end, think of cargo as npm. Cargo allows you to install things which are called crates, and a crate is just an npm package essentially, but for Rust. So, and that's actually what we're going to use to create new apps within Rust on our computer. So Cargo allows us to create new Rust packages right from the command line. As you can see on the actual Rustlang website, documents how to do that. We can just say cargo new, the name of our application, and we can either create a binary or we can create a library. And we're going to be creating a library because what we want to do is just write some helper functions that we're going to import. We're not really writing a full application. So we can just say cargo new number adder --lib, and that's going to create the number adder folder in this directory. And if we look in this source directory, we'll see the lib.rs file. So let's open this up in Atom. This is just the text editor that I use. And we can see we have, let me increase this, a really simple Rust function here, and actually it's just asserting a simple test that it can add two numbers together, which is coincidental. That's what we're going to be doing. Sorry, I just wanted to load up the syntax highlighting here. So we're actually going to delete this kind of boilerplate function here because we're going to write our own pretty simple function. So one thing to quickly point out, so this is obviously where our actual Rust code is going to be written. One of the important things to note is the cargo.toml file. And again, cargo is our package manager, much like npm. So think of this as like your package.json file. This is where we'll list any dependencies that we might need. We're doing something really, really simple, so we're not going to bring in any dependencies. But just like npm or just like gem files or mix, there's lots of community open source libraries and dependencies you can bring in. So we're going to create a what's it called, no mangle function, and this is important because we're going to need this for any time we write a function that we were going to run within our JavaScript library. It's something that just turns off Rust's name mangling. I don't really need to go into too much detail here. It's probably something we won't run into, but I will link to something in the documentation that goes over it in a lot more detail. But again, kind of want to just focus on writing something really, really simple here. So what we're going to write is a public function. So we say pub fn, this is a function, and we're just going to call it add numbers. Now it's going to take two parameters. We'll just call them x and y. And because this is a strongly typed language, unlike JavaScript where we can just say var foo equals 8, we actually have to declare what these variables are going to be. In this case, they're going to be 32-bit integers. So we have to specify that when we declare our parameters for a function. We have to declare that x and y are going to be, in fact, integers, and this function will not accept anything else. We also have to declare what our function is going to return. And in this case, again, it's going to be another integer. But it could be a string, it could be an array, or lots of different types such as vectors within Rust, but we won't get into that here. And we're simply going to return x plus y. So Rust, much like a lot of other languages, does implied return. So the last line of your function is going to be returned. When you start looking through Rust code, you're going to see a lot of lines end with semicolons. Lines that end with semicolons are not returned. So if you write x plus y with a semicolon and you realize you're not getting your number back, that's why. It expects the last line, the implied return line, to not have a semicolon after it. So that's our function right there. Very, very simple. X plus y has to return a 32-bit integer. So how do we get this function that we wrote in Rust into our JavaScript application? So in order to do that, what we need to do is we need to add the WebAssembly target to our Rust toolchain. So when we compile things in Rust, what you're doing is you're compiling it to a really, really low-level language that is understood by the system that it's on. And to do that, we have to add those targets manually through Rust Up. So Rust Up, again, is the thing that helps us manage Rust on our computer. So we're going to run that in our command line, Rust Up. We're going to specify that we're doing something with targets. We're going to add one. And in this case, it's wasm32, then dash unknown, dash unknown. And this can be look really confusing at first. So the way that it works is it looks at the architecture that it's running on first. So for example, if we're running on a 64-bit system, the target would start with x86_64. The next is the hardware, and then finally the operating system. So for instance, a 64-bit Apple system running Darwin, which is the Unix system that Apple uses, it would be x86 64 dash Apple dash Darwin. So it makes more sense when you have a really explicit version of the program you're trying to compile to run on what system. But that's kind of the issue with WebAssembly. We don't know what system it's going to be run on because it's being run on the web, and we want it to run fine on any browser. So in this case, it's WebAssembly, but the hardware and the operating system are unknown to us. We ultimately don't know how it's going to be run. So that's all that really means. It's really confusing at first, but don't be intimidated by it. One of the other things you will notice, a lot of blog posts will list mscripten. So mscripten is required if your Rust program is running any sort of C code or C++ code. Since we're writing pure Rust, we don't need that here, as Rust does ship with its own WebAssembly compiler now. Finally, we specify that this is a tool chain. And nightly is the release channel within Rust. So this is still kind of edge technology. It's not strongly supported everywhere. So nightly allows us to get access to essentially features that aren't necessarily implemented yet. Great. So once we've added that target, we'll now be able to compile our code to Wasm and export a Wasm file that we'll be able to import into our JavaScript. So that gets us most of the way there. There are still a couple things that we need to do within our code itself. So we have our basic function here, just adding the two numbers. But we need to do one thing within this toml file. So like I said, this is where we go to manage our dependencies. We're not adding any dependencies here, but we do need to specify what type of crate type this is going to be. So we need to specify that this is going to be a crate type equal to, double quotes, c.lib. So it's going to be a dynamic library. And much like unknown unknown, that means, again, we don't know what system is going to be run on, so we need this library to be dynamic. So it does mean it's going to ship with more code than it normally would if we're running on a targeted system, but that's kind of required to run within WebAssembly itself. So now that we have that here, we can actually use cargo to compile this for us. So to do that, we're going to say cargo build. Well, I should say cargo build is what you normally would do to compile this down to whatever your default target is on your system. We have to specify that we're using the nightly build because, again, this isn't something that is in the stable version yet. Nightly allows us to use the latest features that aren't necessarily supported in stable yet. We are going to build. We have to specify our target as Wasm32 unknown. And this is one thing I always mess up, and I just did it again. Unknown. So make sure you spell that right because I'll often miss the last N or the second N there. And then lastly, we have the release flag. All this does is tell it to skip building the debug build of our application. Since we're not running this Rust application directly from the command line, we don't really need it. So completely unnecessary because we're just going to be copying the file that it spits out. But if you just want to save a step, we can certainly do that. So there we go. We compiled it. And what it does is it creates a new directory within our project called target. So if you use Atom like I'm using here, the target directory is specified in your git ignores. So you might not actually see it here. I have my ignored directories turned on in this Atom version, but just know that if you go and you open it and you don't see it, most likely it's because it's in your git ignore and your editor is just hiding that. So we want to look at the Wasm32 folders here. And within the release folder, we can see our actual compiled Wasm. And if you try to look at it, it's going to look like a bunch of gibberish because this is really low-level code that we're not going to be able to read. But this is the file that we're ultimately just going to copy and put within our project. So I'm actually going to create a brand new Ember project called Wasm example. And again, I'm building this in Ember because I'm familiar with Ember and it just allows me to get a node system running really quickly. But we're going to just be writing some pretty basic JavaScript. So anything that you want to run or any sort of framework that you want to run in, even just a simple node app should work just fine. But because we are loading in files, you will have to use some sort of node or Webpack. Just because Core's issues, you're not going to be able to fetch the file directly without some sort of server running. So I'm just going to open this new project up in another Atom instance here. And like I said, we're not doing anything specific to Ember. We're just going to write some really basic JavaScript, but I am going to generate a route for my index page. So our simple index route here. And I'm just doing that just so I can have just an entry point for our WebAssembly module. So let's go back to our WebAssembly module here. We're just going to literally copy this, and we're going to paste it into our public directory just so that we can load it up within here. And let's go to our template index, and we're just going to say h1 hi there. Just make sure that this is in fact running correctly. And make sure we delete all this. So we'll just run Ember serve, and this will run on port 4200 on our computer. So here's our really simple app. It just says hi there. And great, does exactly what we expected it to do. So how do we load this WebAssembly file into this application? Well, if you go here to the Mozilla organization, excuse me, the Mozilla WebAssembly documentation page, they walk you through step by step everything that you need to load in a WebAssembly file. So one of the first things that's important is this import object. I'm just going to add this as a constant to my JavaScript file, and this just kind of destructures what comes through from the WebAssembly file when we load it. So literally just going to copy and paste it here. So the import object is a hash that has an import, and it's going to give us the imported function that we need. Because we're working in 2018, most of the browsers have WebAssembly support already. So we can actually call the WebAssembly global object here. And we're going to call instantiate streaming. So we're going to stream the file that we're going to fetch. So we're going to stream the Wasm file, and we're going to get that Wasm file through a fetch call. So we will fetch. So that's the first argument to this function, and we're going to fetch number_adder.wasm. So that's our function there. And the streaming takes one more argument, which is that import object function that we pasted in here. So this is a promise, so we can .then it, and that gives us back an object. Oops. And let's just console log that object to see what happens. So here is our object that comes through. It has an instance. The instance has an exports object, and that exports object is what actually has our function. So that's what we're going to break down. We're going to say, let's just call it foo for now. Let foo equals object dot instance dot exports dot add numbers, and we'll pass it two numbers. Let's just pass it 8 and 7. And we'll just set up an alert. We'll alert foo, or let's call this sum. And there we go, 15. And just to make sure we're doing it right, let's say 80 and 17, which should be 97. When this comes through, 97. There we go. Really, really simple. We wrote our code, again, in Rust. Simply adds two numbers together. We use cargo to compile that to Wasm32. And then we just copied that and pasted it into our JavaScript application, and we called this to import it. Again, I did it in Ember, but this was really basic JavaScript. You can do it really in any system that you want. And that's pretty much it from start to finish. There are lots of things you can do to optimize this even further. One of them is called Wasm-gc. And what this does is it just strips away a lot of the imports and exports, essentially extra code that is compiled with your Wasm file that you just don't necessarily need. So it's a command you can run after you run that build with cargo to make your file even more efficient. But it's not necessary. It's just kind of decreases the size of this. And like I said, we kind of covered a really simple example of just adding two numbers together. But it's important to kind of understand what that workflow is. And by default with Rust right now, the only thing that we can pass to Rust are integers. Passing strings, objects, arrays is a lot more complicated. And to get around that, there's another library called Wasm-bindgen, which is going to allow you to pass things, or essentially it allows you to pass a reference to a JavaScript object or a JavaScript function to Rust, or vice versa, so that you can call things directly and pass more complicated variable types between your two code bases. So if you want to get more into that, certainly recommend checking this out. I'll post that in the description. But again, this was meant to be a pretty simple example. So hopefully this was kind of helpful as a quick introductory to Rust and WebAssembly. If you have any questions, feel free to leave them in the comments. I'm not going to push these repos up because I feel like they're so basic. There's really nothing here. But if people want an example, or maybe a more complicated example, maybe I can mock something up and push that up to my GitHub profile. Thanks for watching.